Now let's see the next type of attribute, which is class. Now if you change the dimension of the object, then it won't change the type of the object. Okay, for example, if you create an object with a type double, then the type of the object will remain double. But by changing the dimension of the object, you are going to change the class of object. So class is a special type of atomic vector. Okay, now R added class attribute to die when you change it when you change its dimension, and this class now describes die's new format. Now remember that many R functions will look for object's class attribute and then handle the object in a predefined way based on the attribute. Now otherwise, how would the R will differentiate between the vector and the matrix, or the vector and the array? So it could only able to differentiate this with the help of a class attribute. So if I can show you the type of the die, so the type of die is double. Okay, but if I use a class function to check the class of a die, then it gives me two classes, matrix as well as array, because we use the die to create a matrix as well as to create an array, right? So always remember, when you attach a dimension to the one-dimensional vector, then the type of the vector remains same. If you create a vector of integer, it will going to remain the integer, but the class of that vector changes. And that is how R could able to differentiate between a one-dimensional vector and multi-dimensional vectors with the help of class attribute. Now let's look at another attribute called dates and times. Now there are more types of data that you can manipulate with the help of R. So far we have used doubles, characters, complex rows, integers. We have seen all these types of objects, but we have not seen dates and times. Now R uses a special class to represent the dates and times. Now to see this, how you can able to use the dates and times, you just have to type sys dot time, and if I run this, then R will give me a current date and current time. And if you check the type of this system time, so for example, if I let me store the current time in an object called current. Okay, in an object called current, and let me now show you type of current. So what is the type of current? So as you can see, the type of current is double, but if I show you now the class of current, now here is an interesting thing. If I show you the class of current, then you will see two different classes here, POSIX CT and POSIX T. Now these two classes represents the time class of R object. POSIX CT is widely used framework for representing a date and time, Now in this POSIX city, it's basically a framework. It's a framework to define the time. It's a framework to represent the time. And POSIX city framework, the time is represented by the number of seconds that have passed between the time, between the current time or between the system time and 12 am January 1st, 1970. In the universal time coordinated zone. Okay, and if I if you want to see the seconds, number of seconds that have been passed since 1st of Jan 1970 till today, then you can unclass current. You can unclass current, and then you can see the time elapsed in seconds. You can see that these many seconds have elapsed from 1st of Jan 1970 till today. So POSIX CT and POSIX XT are two classes which are created so that when you want to check the time, then these classes will convert the second into YYMMDD format of time, and that's what you have seen. But when you want to see the seconds that have been calculated, then you have to remove the class, remove the POSIX CT and POSIX XT class, and that's what we have done. We have unclassed the current time so that we can able to see the time in seconds. That's how it works. Okay. So these are two very special classes that have been created just to handle the time series, time data, time related data, time series data. There is another class which is been widely used. It's almost ubiquitous in R, and that class is called as a factors. So now let's see how the factors looks like. Factors store categorical information. So factors are useful when you want to group the data. Now, what is categorical variable? Categorical variable is characterized by a finite number of levels called factor levels. So for example, gender will have two levels, male female, or true or false. So like that, if you have the variable which you can able to categorized into a distinct levels, then that variable is called as categorical variable. Now factors are helpful when you want to store a categorical variable, and factors will have limited number of these default values called levels. Now how to make a factor? Now it's simple. You will have to use a factor function and pass on the atomic vector into a factor function. Now let me show you how to create a factor in R. Now let me create a factor called gender. Now since I am creating a factor called gender, use a factor function, I will create two levels, male and female. Okay, so male, female, male, And now if I run this and if I display the gender, then this is how I will show the output. Now if I use type of function, then it will give me the gender type as integer. Now what R is doing here, R is simply storing the object called gender as a integer vector, but when it comes to displaying the result, R will add level attribute to the integer, and then it will display the result. That's why when you see here the levels, it has created as male and female because it has attached level attribute to the integer vector. So if you are getting confused of exactly what I mean, then you can use unclass function to check what exactly is going on. So if I use the unclass function on a gender, then you can see that R is first giving the level numbers as an integer to each level within the gender, and then it is attaching levels attribute to each integer, and then finally it is displaying the result as male or female. That means for female it is using it is using second label, and for male it is using first label. If you have a third label here, then I would use number 3 to indicate that to indicate the third label. So this is how the R stores the data, categorical variable data, into the factors. Now this is very important because this categorical variables you can use as a factors in statistical model, and because in factors the variables are coded as levels, so you can use them in statistical model, especially in regression analysis called as logistic regression, wherein you can use to predict the category of that particular variable. Now so far we have seen the vectors, arrays and matrices, and these type of our objects store only a single data type. For example, they store only numbers or characters. But in real world the data sets are not like that. So in real world you get the data sets of sets with multiple type of information. So you have some data sets which have numbers, which will also have the characters, which will also have trues and false, the boolean variables. So the data sets will have a multiple type of information and multiple data types. So then we need to find out some alternative by which we can able to store multiple data types. R gives us two options which we can use to store multiple data types. The first option is list and second option is data frames. So let's see the list and data frames more closely. So let's start with the list. Now list is a special type of a vector that contains the elements of different data types. So list can have a numeric vector, it can have a logical value, it can have a character vector, or there could be a list within a list. Okay, so unlike a vector in which all elements must store the same data type, list can accommodate the vectors of different data types. Now let me show you how you can create a list in R. You can create a list in R by using a list function. For example, list 1. If I create list 1, use list function, and my first element of a list will be a integer vector. My second element of a list will be a character vector, and my third element would be a list which will have boolean values in it. And if I run this, then you can see that the list is being displayed. So this double bracketed value indicates the which element of the list is being displayed. So double bracketed 1 means first element of the list being displayed, which is a numeric vector of length 30. Second bracketed number indicates the second vector in a list, which is a character vector, and the third element of a list is a list itself. And single bracketed number indicates the sub element within the element of the list. So for example, 100 is the first element of a 100 is the first sub element of the first element of a list. Now you can see that the structure of the list is quite complicated. It gives us the flexibility of accommodating various data types, but the structure itself is a bit complicated. Now imagine you have plenty of data set, and you cannot really accommodate the large data set by creating a list. It will become too complicated. So we need to find out some simpler way of creating a data which can accommodate various data types. So we can use a special class of list called data frame, which is much easier and cleaner way to handle a large data set. So let's now have a look at a special type of class of list called data frames. Now you can think of a data frame as R's equivalent to Excel spreadsheet, because they store the data in the similar format. Now data frames are the most useful storage structures for the data analysis. Data frame groups the vectors together into two-dimensional table. Now remember two things. So each vector becomes a column in the table. So each column in the data frame can contain different type of data. As you can see in the figure, it can contain one vector can contain numeric, one vector can contain character, another vector can contain logical. So it can accommodate different type of data sets, as we have seen in the list. But within a column, every cell must be of same data type, and the column length should also be the same. If the column length is different, then you cannot combine those columns in a data frame. Okay. Now let's see how we can create data frame with R. So you can use the function data.frame to create a data frame in R. So let me create a data frame df. Then I use a function data.frame, and I will now create a small part of the deck of cards. For example, face. I will have as ace, then 2, then 6 comma, I will use suit as all clubs. So these are all the cards belong to clubs. And I will use values that represent each of the faces of clubs, 1, 2, 3. So let me run this. I'm getting one error, but I'm not quoted this. Let us run it again. Yeah, so I've run it, and then I will show you how the data frame structure looks like. So this is how the data frame structure looks like. Okay, now let's delve deeper into this structure. Now let's see what type of objects are grouped together in the data frame. So I will use type of function, type of df. Let me run this. You can see that data frame is a type of list. Okay, let's now check the class of the data frame. Now you can see the class of the data frame is data frame. Data frame itself is a different class. And if you want to see the types of objects that are grouped together by the data frame, then you can use structure function. Structure, str stands for structure. So structure data frame, then you can see, yeah, this is how the different objects are grouped together. Now you can see the face and suit. They are character vectors and values are numeric vectors. So data frame gives you a lot of flexibility in terms of arranging the data, because you can use different data types. But there are two conditions to it. All the column length should be the same, and all the elements within the column should have a same data type.